Okay, so this is chapter, what is this? It's chapter 9 in our book, MathLinks 8 on linear relations. And what we're learning in this one question today is, how do we find an equation to match a graph? And the first thing we want to do is, if we look at this graph here, the points, these 3 points form a line. And therefore, we can say they have a linear relationship. Okay? And a linear relationship, of course, when we think of the word linear, we has the word line in it. So when those 3 points, so what that means is when they form a line, they have a linear relationship, which also means there's an algebraic equation that represents the relationship between x and y, or y and x, whatever you want to say. So in order to find that algebraic equation, we need to make, first and foremost, from the graph, a table of values. This point right here is 4 on the x and 22 on the y. So it goes 4 on the x and 22 on the y. This is 6 on the x and 28 on the y, or 6 and 28. And the last point right here is 8 on the x and 34 on the y, or 8 and 34. And when we talk about this equation to show the relationship between x and y, what we do to x to get the y value in every one of these ordered pairs right here, what you learned in grade 7 was you learned to just trial and error. So you said, well, the first thing I'm going to say is, what if I multiplied the x value by, what if I took the x value and added 18 to it, right? Because this 422, x is being 4 and y being 22. If I use the equation x plus 18 equals y, that works for the first pair of 422. But the problem is, it doesn't work for the next one, because 6 plus 18 is not 28. So what we learned to do is we learned to do trial and error to figure out what equation works for all 3 ordered pairs. But for this one in grade 8, we learned that the coefficient of x, or your multiplier for x, will equal the difference in your y column divided by the difference in your x column. Okay? So therefore, I'm going to move this over a little bit here. If I look for the difference in the y column, the difference in the y column is adding 6 each time. So right here, the difference in the y, I'm going to put a positive 6 where my difference of y is. My difference of my x column is adding 2 each time. So I'm going to put that here for my difference in x. And therefore, if I think about what is positive 6 divided by positive 2, it's positive 3, or just, I'm going to make it just a 3. And because it's a 3, that means in the relationship between x and y, 3 is going to be your multiplier for x. Okay, that's your coefficient of x. And once I know that, then I can take any of these ordered pairs, it doesn't matter which one. Usually what we'll do is we'll take the first one, 4 and 22, and we'll substitute it into our equation. So x is 4, y is 22, and I'll simplify it. And if they are the same on both sides, that means your equation does not require a constant. But because these two are not the same, that means I require a constant to balance them. And that constant is a positive 10 or a plus 10, which means this is the equation that matches every one of these points on the chart. So 3 multiplied by the x value plus 10 will equal your y. So going back to my table of values here, if I take any of these ordered pairs, and I'll do the middle one this time, 6 and 28. If I multiply the x value by 3, 6 times 3 is 18, and 18 plus 10 is 28. So that works for that one. If I take this one here and multiply the 8 by 3, I get 24, plus 10, I get 34. So it works for all 3 ordered pairs. And that's how you take a graph and find the equation from it.